Assalamu alaikum students. This is new video number 3, lesson number 3. In this lesson, I'm doing another question. In this question, they say for the curve y is equal to x squared plus 4x plus 10. Let me write here the topic, which is differentiation. I'm writing with the red color. Or differentiation, IGCSE, math, or standard mathematics. Extended math always. Now, this topic has been introduced in the syllabus for mathematics. That's why we are doing this to students. Usually, this topic is taught in A-level and AS. Now, the question says for the curve y is equal to x squared plus 4x plus 10, work out the value of y when x is equal to 1. Very simple thing. Part A is very simple thing. Part A is from here. Part A is work out the value of y when x is equal to 1. So when x is equal to 1, what's the value of y? Y is x squared plus 4x plus 10. So y is equal to 1 squared, just replace 4 into 1 plus 10. So y is equal to 1 plus 4 plus 10. This result becomes 15. Now that's the result for first part. For second part, part B, work out the value of dy dx when dy dx when x is equal to 1. Now first of all, find dy dx. To get this, look here, the function is x squared. So if x squared is differentiated, we get 2 into x power 2 minus 1. And if 4x is differentiated, it becomes 4. And when constant is differentiated, it becomes 0. So result becomes dy dx is equal to 2x plus 4. That's the result. Now, if you remember, I have told you that this thing is basically your gradient, your m. Or I can write here gradient. Okay, that's right. This dy dx is basically our gradient. This I have explained to you, I have told you in the previous lesson that dy dx is your m or gradient. When we substitute the value of x which is given to us in the question. So if x is equal to 1, then dy dx becomes 2 into 1 and plus 4, which is 6. And you know, always the m value, which is gradient, is always coming some constant number, negative or positive, sometimes fraction, sometimes 0, sometimes even undefined. So this is the value of m. The dy dx basically your gradient or your m. Now we got that part B. Now part C. I'm doing part C here. Part C is say, thus find the equation of tangent to the curve at the point where x is equal to 1. So see here, I'm just making a rough sketch, which is just a rough sketch, which is not the exact sketch of this function. If x is here 1, if x is 1 here, what is the value of y? To get the value of y, see, we substitute the value of x1 here, so we got 15. So that is a point. They say find the equation of the tangent to the curve. It means they are saying to us that there is a tangent line to this curve. Find the equation of this tangent line. Now you see this thing which I'm doing here. This is not part of the question. If you don't do it in the question, it's not making any difference. Okay. But you know why I'm doing this sketch and this point I'm making here and I'm making tangent. I want to make it very clear. The picture of the question, I want to make it clear. So if you are doing it in the, this thing in the question, it's very good. It's very good. But it's not required in this question. You can even do it directly. So directly I'm doing here y is equal to mx plus c is the tangent equation. You know, tangent is always a straight line. So c y is equal to the value of m is what? It's 6x. How to find c? C is put this value of x and value of y. So value of y is 15. Value of x is 6 into 1 plus c. So c becomes 15 minus 6, which is becoming 9. Equation of tangent becomes what? Equation of tangent becomes y is equal to 6x plus 9. That's the result. That is part C. I hope it's clear to all students. Now, let's do one more question. I'm going to erase this part, this question from whiteboard. I hope you will be copying it. So, let's move to next question. Let me bring question number 6 here. Question 6 is here. That's question 6. Okay, I'm just minimizing this. Okay. Now, this is question 6. Question 6 says, question 6 is saying that for the curve y is equal to 15, curve is y is equal to 15 plus 6x minus x squared. That's the curve equation. And I'm always asking my student to make it write this in order. In order means x squared, x and then constant. 6x plus 15. Now this is in order. So first of all, I'm doing part A. Part A says work out the value of y when x is 3. Even you can do it here. Just put the value of 3 here. Y becomes 15 plus 6 into 3 and minus 3 whole square. So 15 plus 18 minus 9. So 15 plus 9 is what? Is 24. So that is the value for y when x is 3. Now work out the value of dy dx. So how to find dy dx here? Let's do part B here. Part B is dy dx, which is minus 2x and 1 and plus 6 and plus 0. So that is the value of dy dx, which is minus 2x plus 6. Now, yes, they say work out the value of dy dx at 3. So if we substitute the value of x3 here, it becomes minus 2 into 3 plus 6, which is becoming 0 here. So it means dy dx becomes 0 here. Now, last part is part C. They said thus find the equation of tangent to the curve at the point x is equal to 0. So see, parabola is opening down. I'm just making a rough sketch here. Parabola is opening down. At this point 3, this is the tangent to this curve. Now, equation of this tangent is always in mx plus c form. So y is equal to, what is the value of m? Already we got m here. this is your m, this is your m value. Sorry, it's not visible, so I'm erasing it. This value, you see students, I have told you that this value is your m value. So m is becoming 0, so 0x plus c. How to find c value? There are two values, x and y values. We are given with the value of x and we found the value of y. You can see here the value of y, and you can see here the value of y is here. Yeah, the value of y is here, students. This is the value of y, and this is the value of x, which is 3. Now, so put these values. Here is 24, 0 into 3 plus c. So c becomes what? C becomes 24 is 0 plus c. So c becomes 24. Equation becomes 0x plus equation becomes 0x plus 24, or y is equal to 24. Now, one very small thing I want to tell you. When the line is parallel to the x-axis, C is parallel to the x-axis, equation is always in form of y is equal to the constant. Y is equal to c, y is equal to d, y is equal to e. It's a constant value. So see, we got exactly that thing. Y is equal to 24 is the result. So that is for question number 6. I hope you will understand this question. And now I'm doing another question. Okay, I'll bring question from book. Now question number 7. I'm not doing question 7. I will do question number 10. Okay. Question 10 is a very good question. Yes. Let me minimize this thing so that we can see it completely on the whiteboard. Okay. Yeah. I hope you will be able to see the question now. Yes. Okay. Question is visible, but just make it more smaller. Yeah. Now see, what is the question saying? This is a good question. This is a very good question. Question says that for the curve y is yq, for the curve yq, y is equal to x cube minus 12x squared plus 15. Work out the value of dy dx. Now, how to find dy dx? See, I'm doing it here. Even let's do it here. So if y is see, y is given to us x cube minus 12x squared plus 5, then dy dx becomes what? 3x squared minus 24x. That's the derivative of the function. Okay, so we got a derivative. That's part A. In part B, they say solve dy dx equal to 0. So very simple. When dy dx is equal to 0, it means 3x square minus 24x is equal to 0. So 3x is common. So x minus 8 is equal to 0. So 3x is equal to 0 and x minus 8 equal to 0. So see, we get the value of x 0 and x is equal to 8. So these two values we got. Then in part C, part B we did. In part C, let's say find the coordinates of the turning point, stationary point. I have told you students that basically this is also stationary point and this is also stationary point. Okay, to get this turning point or stationary point, dy dx will be 0. We will put dy dx 0 here. Now see here, there is another case here. Now y is equal to ax cube plus bx square plus, let's say, cx plus d. This is a cubic function. It's called cubic function. Now in cubic function, if the a value is greater than 0, then the curve will be always this thing. So this is one stationary point and this is another stationary point. Okay, now if a is less than 0, then the curve will be always this one. So this is one stationary point, that is another stationary point. Okay, now this point, you know this is maximum point, maximum, and this point is minimum. I have explained these things, but in the cubic function, this is now cubic function. Cubic function is a different thing. There are, see, one side is coming, see, in the when a is greater than 0, the left side is coming down and right side is moving up. But there are two stationary points, two turning points. One point is here, one point is here. This is maximum and this is minimum. And in the second case, when a is less than 0, see, in this case the left side is moving up and the right side is moving down. So remember these things about the cubic function, that the cubic function can be either in this form or in that form. Then there will be a maximum point and minimum point. Okay, now let's do the question. I'm erasing all these things and go to the question now. Look at the function. The function is x cube minus 12x square plus 5. Now tell me, the curve is in which form? Either this will be in this form or this will be in this form. Now tell me, this is A case, this is B case. Whether the curve will be in the shape, in this A shape or in B shape. Look at the function. It's x cube minus 12x square plus 5. Look at this value. This is a. In this case, a is greater than 0. So it means the curve is this way. Or let me do it here. The curve will be in this way. Now we got x value 0. If x value is 0, y value is what? 0 minus 0 and plus 5. So one point A is 0 and 5. If x is 8, y is 8 power 3 minus 12 into 8 power square and plus 5. The result is becoming 8 into 8 into 8. So 64 into 8, 8 4 32, 8 6 are 48, 48 plus 4 is what? 52. So 522 is coming here. Then 64 into 12. 12 4s are 12 6 are 72. 72 plus 4 is 76. So minus 7, 6, 8 and plus 5. Now come and get the result. 7, 6. I don't have calculator right now, so I'm doing it mentally. 6 and 4 and 2 and plus 5. This is becoming negative. Okay, so plus 5, it's becoming minus 241. So the y value is coming minus 241. So one point is 8 and the other value is minus 241. Now, okay, one is x0, one is x8. So of course x0 will be here, which is 0 and 5, and this point is 8 and minus 241. So now which one is maximum? This is, sorry, I did a mistake here. I think one is yeah, it's fine, that mistake. So 8 and minus 241, yes. Let me check it again. 8 8s are 64. 64 into 8 at 432. 832 and at 6 are 48. 48 plus 4. Oh, no. 8 4 6 6 48. 48 plus 3 is 51. This is 51. So it's 512, not 515. Okay, so 6 here and 5 here. So 5 here is 1, 251. Yes, it's 251. So it's 251. Students, please correct this thing. So one point is 251 and one point is 5. Now there are 2 points, 2 turning points. One is this value, the other one is this value. Now which of these is maximum? It's very clear that this point is maximum point and this point is minimum point. Now they are asking, and show your reasoning. What is the reason for this maximum minimum value? Look at the value of y here. Value of y is 5. Look at the value of y here. This is minus 251. Which value of y is bigger? 5 is of course bigger, and minus 251 is smaller. So that value is maximum value and this value is what? Minimum value. I hope it's clear to all. Inshallah, we will be meeting in next video. So please see watch these videos, see the questions and the working very carefully, and basically do this working yourself. And when you watch this video, then do the same working yourself and check the question and check the answers. Compare the answers with my working and then do it yourself again, and then understand the thing and then do some other question with the same method. Inshallah, you will learn this method and this theory, inshallah. Okay, Allah Hafiz.